All right, so I just want to explain this underlying reference or whatever a little bit more, and I didn't get that completely in the last video, and so here I just built on this first example here to illustrate it because I feel like this is a little bit more clear. So we have our map, and it's a key of string and a value of int, and then we add some keys and values to it, keys and values, and then we print it out, and we see the type, and then we also add a value this way, and then we print the map once more, and we get this right there, right? Like all three values in that map. And then I create a slice that's going to hold this type, right? And a composite literal right there just to initialize that slice and create it. So that's what the curly braces are there for. And so that's like, you know, hey, that'd be the same thing as if I had a slice of int colon equal, and then I make slice of int, and I need that right here, and then I put values into it. So it's like creating this data structure and then storing values there. If I don't have this composite literal, it's like just trying to declare a type, and that's not an expression, right? It's not an actual value, but this would be if I put values in there. Xi declared not used, so I have to actually use it. So there we go, and then format and run, and that Xi prints out 2, 3, 4. So here, that's what I'm doing. I'm just creating a slice which holds a value of this type, and it has to be an expression. So which means like it has to return a value, and it's not just a type, but hey, there's a value here, and so I'm assigning that value of this type to xm, and then I'm appending to xm the map which is of this type, right? So I'm appending this map up here, which is that type. I'm appending it to xm, and then I print that out. And right here I get this, which is all that printed out. So the outer brackets are the slice. And then down here, I change m, which used to be this key had 65 value. Now that key has 66. So in this map, right, that map, I am changing the key m to store a value 66 instead of 65. And then I append that map back here. And so now in XM I have two maps. And so here's my first map, and here's my second map. But both of the m's are 66. You can see that right there, right? So we lost that 65. And that's because this map, right, what's stored there is the map is looking at the underlying data structure which holds the keys and the values. And we've changed that underlying map where m is, to be 66. So when this first one looks, okay, what is m? Right, it's 66. And the second one, it's now 66. So even that one changed. So it's an underlying reference data structure. I don't know. Hopefully that gives you a little bit more clarity. I guess we could read about this at the Golang spec. I'm just rambling a little bit here and just continuing to explore it while it's being recorded. And if we look at Golang spec and look at type map, we can see what it says here. And in effective Go, we could also look to see what it says about maps. Convenient, powerful, built-in data structure. Associate values of one type to key with values of another type, element type. Key can be of any type for which the quality operator is defined, such as integers, floating point, so we could have any keys. And slices cannot be used as keys. And like slices, maps hold references to underlying data structure. If you pass a map to a function that changes the contents of the map, the changes will be visible to the caller. So it's an underlying data structure, right, underlying the map. Maps can be constructed using the usual composite literal syntax. So here's that composite literal syntax, the type, and then curly braces, and then the values. And I'm just looking to see if it tells us any more. And what I'm kind of looking for is I know that with a slice, there's three things in that data structure, a slice. It's the length, the cap, and the reference to the underlying array. And I'm just looking to see how maps are built because I don't know that yet. A map, that's a hard phrase to say. A map is an unordered group of elements indexed by unique keys. The value of an initialized map is nil. Comparison must be defined for the key type. And the number of map elements is called its length. For map in, it can be discovered using built-in length and may be changed. Elements may be added during execution. A new empty map is values built-in function make. make map, map, and optional capacity hint argument. So a hint, how many values are going to be stored there. Initial capacity does not bound its size. Maps grow to accommodate the number of items stored in them. The accession of nils. The nil map is equivalent. So what I was just looking for is like a little bit more information on the implementation of a map, but underlying data structure is all I know about a map. And so as you change the map, whatever's looking at that sees those changes. And so that's what's being reflected in that M66, M66. I hope that gives you a little bit more clarity.